Good morning, everybody. Welcome to another cloudy, overcast, maybe snowy Chem 1211 with your host, me, Dr. White. Hi, everybody. Be careful. It's March 15th, the Ides of March. For those of you who read Julius Caesar in high school, et tu, Brute. Ah. For those who don't know the reference, this is supposedly the day Julius Caesar was knifed in the back by a bunch of people, killed. The last one to do it was his good friend Brutus, et tu, Brute. That's all the Latin I know. Anyways, let's get started. First of all, let me remind everybody, starting this Thursday, you got 2 days to hand in by Sunday. I'll make it Sunday for everybody, your labs. If not, you'll get 0 points. So make sure you hand in your labs on time. The labs you handed in this last Thursday, tomorrow I'll post the scores in Blackboard. One thing I'll mention it now. The way I graded it for the balancing chemical equations lab, if you got everything right, you got 10 points. 1 or 2 wrong, 9 points, 2 or 3 wrong, 8 points, 4 or more wrong, 7 points. I didn't feel I wanted to go below 7 if you made a good attempt to hand things in. So, and always when you get a lab back or points in your case, always feel free to ask, why did I get that? Come to my office hours or after lab. I'll be more than happy to explain why I gave you that score. All right, another important thing I do want to mention, and that is over the weekend, I was reading a great article in the New York Times. By the way, daily I read New York Times, Washington Post, Huffington Post, and a few other things like 3 Twitter accounts, Paul Krugman from New York Times, and 2 others from Washington Post. In the New York Times, there was a great article by this instructor, professor from University, I think of Utah. And in that article, he talked about the problems he was having teaching face-to-face on Zoom, like this, teaching not face-to-face, but on Zoom. And he finally realized, and this professor teaches philosophy, I teach chemistry in case you haven't figured that out. But anyways, like I said, it's Weird Humor Monday. He said, I wasn't feeling into my class, even though I am, but it's not the same as face-to-face. And he pointed out, because you're not seeing people, you're seeing mostly names. And he finally leveled with the students. Instead of saying, please put it on your camera, he said, the more of you, and I'm going to do the same thing, that turn on your camera, the more energy I get and the more pumped up I am, and the better I feel, and I think the better job I do. So if you can, please turn on your cameras. All right, public service, and those of you are, thank you. Because it's good to see faces, and I'm really talking to live people, not just names out there. All right, next thing, let me remind you, tonight and Wednesday night, I have my office hours. Feel free to come. Also, it's still available. If you want, you have a group of people, you want to get to connect together, and you don't have Zoom, come to my office hour, and I'll put you in a breakout room where you guys can just be together and work together, or whatever you do together in a breakout room, hopefully chemistry. But that's my offer to you. Oops, that's not what I wanted to do. Thank you, happy Ides of March. All right, one other thing I do want to mention, and that is for those who had lab, you notice I had a lot of internet problems. I got bounced off a couple of times and I had to come back. Half hour after the class, the rest of the day, I better keep my mouth shut. The rest of the day, no problems, never since. So what that meant is I had a lot of problems with the video. I'm not going to post the video for the Friday lab. Look at the Thursday lab, it's almost identical, other than the names have changed to protect the innocent. No, that came from Dragnet. But anyways, for those who don't know what Dragnet is, look it up on Google. Oh, I just did a generation gap. Dr. White rarely, if ever, uses Google as a verb. I use it as a noun. Ooh, my second grade English teacher will be smiling now. All right, let's get to work. Last week, I taught you about the fact that the coefficients of a balanced chemical equation indicate molar ratios. Thumbs up, people. You see the whiteboard? Thank you. And if we look at this balanced chemical equation, the coefficients, the number in front, when there's no number in front, it's really the number one, tells me 2 moles of hydrogen react with 1 mole of oxygen to make 2 moles of water. It's one of the most powerful things I know in all of chemistry. The coefficients of a balanced chemical equation give you molar ratios. 2 moles of hydrogen react with 1 mole of oxygen to make 2 moles of water. And therefore, I can make various ratios, such as 2 moles of hydrogen make 2 moles of water. And I can also have another one, 2 moles of water make, you need to react 2 moles of hydrogen. And by being able to make these ratios, we can use our good buddy, our good friend, unit analysis to do a lot of important things, like how much to mix together to make certain chemicals like you use in your daily life. And thumbs up, people. You see the problem on there? Thank you. All right, let's look at the following. I'm going to do this one, and you know I'm going to share so you can have fun too. And the question is 10 points. How many grams of water are made if you react 8.66 grams of hydrogen with an excess of oxygen? When you see excess of a chemical in a reaction, that means ignore it because you have all the oxygen in the world that will react with anything in this reaction oxygen can react with. So first thing is, what am I being asked to find? And the answer is grams of water. What am I given? 8.66 grams of water, of hydrogen. Got water on the brain, I guess. And you're given this balanced chemical equation. 2 moles of hydrogen react with 1 mole of oxygen to make 2 moles of water, H2O. Now, there's no way you can go from grams of hydrogen to grams of water. No way. What you have to do is used for mass calculations, and mass means grams. For reactions, it's 3 steps. And this you'll be given an important information, test number 2. Students in my class years ago, about 3 years ago or longer, would have to memorize this. I no longer am doing that, but you have to know how to use it. And step one, whatever you're given in the mass of, meaning grams of A, you convert to moles of A. Step two, you convert moles of A, what you just figured out, to moles of B, the compound you're trying to eventually find the answer for. And finally, moles of B to grams, mass means grams of B, which reminds me, I better mention something. Don't forget, this Thursday and Friday, I will be going through Chapter 8 problem set. Make sure you try them before I do. That will help you on test number 2 coming up, I believe, next week. Later in the week, I'll talk more about test number 2. So how do we proceed? Step number 1, whatever we have in grams will convert to moles, grams to moles. Well, this is what we're given in grams, and we have to convert it. You're guilty. I said it's weird humor Monday. Convert it to moles of hydrogen. How do we do that? Well, we have 8.66 grams of hydrogen, and we want to get to moles of hydrogen. And guess what time it is? It's time to use your good buddy, your good friend, unit analysis. Love it. I do love unit analysis. It's been my good friend and buddy for many decades. And how do you use unit analysis? Whatever you're trying to get to goes on top of the ratio. Whatever you're trying to get rid of goes underneath. And I'm talking about the units at this point. And where do we get a ratio of moles to grams of a compound? And if you look at, and I've got to open it first. I'll be showing you, Kelly, in a second. How do we figure out how to go from grams to moles? 1 mole of a compound equals the molecular weight of that compound, and the molecular weight of that compound equals the sum of all atomic weights. Now, just had a question. How do we figure out we're supposed to go from grams of hydrogen to moles of hydrogen? In mass calculations, which we're doing, step 1, whatever you're given in grams, that's hydrogen, you convert to moles. And that's how you know what to do. Also, you're not going to be able to solve the problem if you don't start out that way. Thank you. Remember, in my class, there's no such thing as a dumb question. Never. Always feel free to ask questions. All right. And thank you for your question, Kelly. All right. Now that you know 1 mole of a compound equals its molecular weight in grams, we've already done this enough time. The atomic weight of hydrogen to 3 significant figures is this. For oxygen, which we'll need later, is this. So I have for hydrogen, I have 2 hydrogen. Each one is 101. And that, remember, this is an exact number. This is 3 significant figures. And my answer, because I'm only doing multiplication, is 3. So for every 1 mole, you have 2.02 grams. And before I pick up my calculator, do my units cancel out to give me the right answer here? Check this, don't just assume. Grams of hydrogen divided by grams of hydrogen. Remember, anything divided by itself equals the number 1, cancels out. I get the right units. And now I can go to my calculator, which first I have to open up. Thumbs up, people. See my calculator? Thank you. And now I'll go here, plus 8.66 divided by 2.02. And that's the number I get. Nope, we're not doing that yet. Gabrielle, it's a good question. Let me do the number and I'll come back and answer your question. We get back to the other page. All right. So, oh no, he's in his 3 significant figure rut. I'll let you round that off to 3 significant figures. Time's up. Keep the 4, keep the 2, keep the 8. Use the 7 to round off. That's 5 or higher. Drop all this, increase that. So it'd be over here, 4.29. Now the way I have the cells formatted, ignore the zeros. Now, as I mentioned earlier, do you round off at each step or at the very end? I'm an each step person, but I know people are very end round off persons. You can do it either way. I will calculate it both ways for the test answers. Now, one of your colleagues just asked the question, why not put 2 there? Because the definition is 1 mole compound equals the molecular weight in grams of the compound. So at this point, we're just going simple calculation that you learned already for chapter 6, grams to moles of a compound. And that's why this is the number 1. So now we've done step 1, and we need to do step number 2. And step number 2 is convert moles of A, which in this case is hydrogen, to moles of what we want to eventually get our answer to, which is, let's find out, go back, in case you forgot, water. So step 2 is this, moles of hydrogen to moles of water. And where do we get that number? Well, we use our good friend, our good buddy unit analysis. Here we just calculated moles of hydrogen. If I could convert this in one step using a ratio, what do I want my answers to be? Moles of water. And now I'll use my good buddy, my good friend, I don't want to wear out the whistle yet, unit analysis, whatever I'm trying to get to goes on top of the ratio, whatever I'm trying to get rid of goes underneath. And where do I get a ratio of moles of water to moles of hydrogen? I have to go up to the balanced chemical equation And notice for every 2 moles of hydrogen, I make 2 moles of water. Why aren't we using oxygen? Because we don't need it. We're looking for a relationship between moles of hydrogen and moles of water. And we get that from the balanced chemical equation. For every 2 moles of hydrogen, we make 2 moles of water. Again, for every 2 moles of hydrogen, we make 2 moles of water. So I can come back down here. For every 2 moles of hydrogen, I make 2 moles of water. Now, in this case, we don't have to worry about it, but remember, both of these are exact number, 3 significant figure. Oh, I'll go to my calculator. No, I don't need that. And we get this. So now we have moles of water. Are we done? No, because we're trying to find grams of water. So we need step number 3. And step number 3, if we go to important information, test number 2, you'll see step number 3, whatever we now have in moles, which in this case water is B, we convert to mass, which is grams of B. Well, how do we do that? We want to go from moles of water to answer grams of water. And we now have 4.29 moles of water. And we want to get to grams of water. So I use my good buddy, my good friend, unit analysis. Remember, I'm still trying to go for the Guinness Book of World Record of saying that the most times a semester. I think I'm winning. And whatever we're trying to get to goes on top of the ratio. The units, whatever we're trying to get rid of, go underneath. And now I'll write that in. And where do we get those numbers? Well, let's scroll up. 1 mole of a compound equals the molecular weight of a compound, and the molecular weight of a compound is the sum of all atomic weights. And for molecular weight, water, I have 2 hydrogen, 1 oxygen. We've done this before, so I'm going to do it quickly. We add these 2 numbers. When you add, you get the same number of significant figures to the right of the decimal. This is the number that has the fewest. This is 2. Oh, that's ugly looking. That's better. Not really. This is 1. Keep the 0. Use that to round off. So for every 1 mole of water, there's 18.0 grams. And before I pick up my calculator, do I get the units I want? And notice moles of water divided by moles of water, anything divided by itself equals 1. Let's try that again. And therefore, this cancels out. I'm left with grams of water. So I'm going to go to my calculator. And if we round these both, oh my goodness, it happened again. If we round these off both to 3 significant figures, this one keep the 7, keep the 7, keep the 1, use the 6 to round off, drop that, increase that to 77.2. This one, keep the 7, keep the 7, keep the 2, drop use the 2 to round off, that's 4 less, drop that, and that's 77.2. So the answer here is 77.2 grams. And now All right. I'll get to your question in a second. No, then hold on. And this is the answer. And whether you round off at each step or at the end, I'm an each stepper person. If you haven't figured out by now, you get the same answer. Now, once again, one of your colleagues asked, in the ratio, shouldn't that be 2? And the answer is no. And why shouldn't that be 2? Well, let's find out. This is for molar ratios between compounds. 2 moles of hydrogen, 1 mole of oxygen makes 2 moles of water. That's only for step 2. For step 1 and 3, you use 1 mole of a compound equals the molecular weight of a compound. And I could have given you, if you have 4.29 moles of water, how many grams? And I don't have to show you any balanced equation, because this is always going to be 1. This is going to be the molecular weight. And that's how you do it. Hopefully that answers your question. And like I said, all questions are good questions, because now you won't get that wrong on a test. And I'm sure some of your colleagues might have had a similar one, and they won't get it wrong on a test, which is a good thing for you and me, because it makes Dr. White happy to see students succeed. All right, time for Dr. White to share and let you have some fun. Now, you already learned, or hopefully you have, that you need atomic weights. So I'm going to give you 2 important ones. You can look it up on the periodic table, and I hope you all know how to do that. And remember, I'm going to give you a hint. Here's my hint. On test, I won't do this, but today I will, because Dr. White's a nice guy today, and hopefully tomorrow and the next day. Your turn. And as I mentioned at the top of the hour, it makes me do a lot better job if you turn on your webcam. So if you can, turn it on and help Dr. White out. Oh, it warms my heart to see all you people doing chemistry on a Monday morning. Thank you. Hopefully it warms your heart too to think, I can do this tough stuff, or I'm starting to know how to do this stuff. This is some of the toughest stuff you'll learn this semester. While you're doing that, I'm going to go out and look at the real world and see something. Oh no. Important weather announcement from Dr. White. In the Chicagoland area, they're now forecasting, hopefully they'll change it, over almost 4 inches of snow. Oh no. Aren't you glad you don't have to go to COD on Wednesday or Tuesday? Yeah, hopefully you don't have to. 4 inches. Well, I think I told you the story about April the 14th, back when I was a junior in college. We had 14 inches of snow the day before tax day. Uh, it's April. Uh, Sorry about that. Those of you who have classes this afternoon. That's true. I wait until April, even though uh, Gabriella, I usually get my seeds from a place called Johnny's Seeds a couple semesters ago, more than that, a year and a half, 2 years ago. I had one student who worked at a really big greenhouse, plant place in the suburbs here. And I asked, where's the best place to get seeds? And she told me where they get them. I'll probably do basil, dill, and I'm thinking, what else should I do? Dr. White loves basil, mozzarella, and tomatoes with balsamic vinegar and some olive oil. Oh my God, I'm getting hungry already. Speaking about Home Depot, about a year and a half ago, or was it last, I think it was last winter, so a year ago, a little more than a year ago. They don't have it in the store, but you can order it online. They have these yellow blade snow pushers that are real good, made out of all plastic that you order online. And when it's real powdery, or there's not much, but it's real icy type, but not true ice, these things work much better than a snowblower. Plus, gives me the exercise I can always use. You see, people are still ciphering out there, so I'll give you another 25, 20 seconds. Well, let me do this. 4 inches. I'm tired of snow. I love it as long as I don't have to shovel it. My driveway and I spent a lot of quality time this winter together, along with my shovel and snow blower. All right, looks like just about everybody's done. Let's do this. And the question is, how many grams of HCl, hydrochloric acid, are produced if you react 75.5 grams of chlorine with an excess of hydrogen? So, first thing, what are we being asked to find? And the answer is not, I just took it off the screen. Grams of HCl. What are we given? As soon as you see an excess of anything, in this case hydrogen, you can ignore it. So I'm going to cover it up so I can ignore it. And you're also given this balanced chemical equation, which tells you 1 mole of hydrogen reacts with 1 mole of chlorine to make 2 moles of HCl, hydrochloric acid. So how do we begin? The first step, whatever you have the mass of A, you convert to moles. Well, the only thing we have mass of, the only thing we have anything of, is 75.5 grams of chlorine. And step 1 will be grams of chlorine, that's mass of A, to moles of A. In this case, that's chlorine. So it's time to use your good buddy, your good friend, unit analysis. Whatever I'm trying to get to goes on top of the ratio. Whatever I'm trying to get rid of goes underneath. And where do I get these numbers? 1 mole of a compound equals its molecular weight. And the molecular weight of chlorine gas is 2 times each chlorine atom atomic weight. Remember, molecular weight of a compound in grams is the sum of the atomic weights of all atoms in that molecule. And each chlorine is 35.5. And if I did my math correctly, that's 71.0. And I think I did. So this is 71.0. And now, before I pick up my calculator, I'll look, do my units cancel out? And notice I have grams of chlorine divided by grams of chlorine. Anything divided by itself equals the number 1, cancels out. I'm left with the right units. So I'm going to go to my calculator. And this is the number I get. Now, I'm going to round off at each step, round this off to 3 significant figures, keep the 1, keep the 0, keep the 6, use the 3 to round off, and that would be 1.06. So at this step, I have 1.06 moles of chlorine. Now we have to do step number 2. Moles, in this case, or whatever we just calculated, chlorine, moles of A to moles of B, the answer we're trying to get. And if we come up here, that's HCl. Eventually we'll get the grams, but at this step, we're doing moles. Well, I know I have 1.06 moles of chlorine. I want to get the moles of HCl. So it's time to use your good buddy, your good friend, unit analysis. Whatever I'm trying to get to goes on top. Whatever I'm trying to get rid of goes underneath. And this is moles of HCl. This is moles of chlorine. And where do I get these numbers? From the balanced chemical equation. And if we come up here, wherever, there it is, 1 mole of hydrogen, well, that's an excess, I can forget about it. 1 mole of chlorine makes 2 moles of hydrogen. Remember, the coefficients give you the molar ratios between compounds or elements in a balanced chemical equation. So from this one, I know 1 mole of chlorine makes 2 moles of hydrochloric acid, HCl. So for every 1 mole of chlorine, I make 2 of that. These are exact numbers and play no role in the calculation. 3 significant figures, my answer should. So I'm going to go back to my calculator. And this one, wow, it comes out where this is 3 significant, 2.11, and this will round off later. So the answer at step 2 is 2.12 moles. Am I done? Well, I got moles of HCl, but the answer is no, because I want to get to grams of HCl. So now I have to do step 3. And that's moles of B, whatever I'm trying to get to. In this case, B is HCl, to grams of that, grams of HCl. And I have 2.12 moles of HCl. I want to get to grams of HCl. How do I find what's in this ratio? I use my good buddy, my good friend, unit analysis. Anybody having nightmares hearing me say, use your good buddy, your good friend, unit analysis, or worse, hearing it with my whistle? Hope not. But anyways, whatever I'm trying to get rid of goes underneath. Like I said, whatever I'm trying to get to goes on top of this ratio. I now know what to put in there. And before I pick up my calculator, I have moles of HCl divided by moles of HCl. Anything divided by itself equals the number 1. Therefore, these cancel out, and I'm left with the unit I want, grams of HCl. Now, where do we get those numbers? Remember, 1 mole of a compound equals its molecular weight. And the molecular weight of HCl is 1 hydrogen, 1 chlorine. Remember, these numbers are the atomic weights. I add them together. And remember, when you add, you get the same number of significant figures to the right of the decimal as the number you're adding that has the fewest to the right of the decimal. This is 2, this is 1. Therefore, my answer should have 1 to the right of the decimal. Keep the 5, use the 1 to round off. That gets dropped, and that's 36.5. And now I'll go to my calculator. And if you notice, you do get a different answer now, depending how you round off. Turns out in a chemical plant with the accuracies of measurements, if you're doing a large amount, this little difference won't make a difference. How do I know? Because I've used this to calculate things that cost hundreds of thousands of dollars in chemicals. All right, round this off. That would be three significant figures. Keep the 7, keep the 7, keep the 6, and I get 77.6 grams. Do the other one, keep the 7, keep the 7, keep the 3. Use the 8 to round off, drop that, increase the 3 to 4, so that's 77.4. And I would accept these two as the answer. They both would be correct. And that's how you do it. Now, one of the things that I saw a couple of you have a little, how should I say, confusion with. Let's go back and look at what we just did. When you go from grams of a compound to moles, that's 1 mole equals the molecular weight. And this will be given to you important information. So this 1 comes from this relationship. 1 mole of a compound equals the molecular weight, which is what I have here in step 1 and also here. The relationship between grams and moles is based on 1 mole of a compound equals the molecular weight of the compound. Now, where do you use the balanced chemical equation to get molar ratios? Only in step 2. How do you know that? Because we're trying to get the relationship of moles of one compound to moles of another. When you have the relationship of moles of one compound to moles of another, step number 2, use the balanced chemical equation. Where'd you go? Oh, here it is. And it tells you 1 mole of hydrogen reacts with 1 mole of chlorine to make 2 moles of hydrochloric acid, HCl. And if I look at my 1 clock, they're off by about 10 seconds. It tells me it's time for Dr. White to stretch and to give you a 5-minute break. And I'll see you at 10:55. Do come back. I'll be back. Oh no, I'm running a minute late. I'm going to go till midnight because I cheated you out of a whole minute. No, I'm not. You look out the window, oh, it looks like something nasty is about to happen. Which, if you look at the weather underground for Chicagoland, it is later today and tonight. But anyways, let's get back to work. Hopefully the last segment, you learned everything you were wanted to know and even were afraid to ask about mold problems. Let's move on. Now, another area I talked about, we went through this last week, but I like to go through it again today. And we're doing just like the previous uh, grams to grams problem, which we'll do more on Thursday and Friday from the problem set, chapter 8. Let's talk about what happens when a reactant is totally used up in a reaction and another reactants are in excess. And this is called limiting reactants. I've been pretty good. I used to always call it limiting reagents, which is wrong. But, and remember my analogy. Let's see if I can find it. Got it. If you're a company that makes pens and you buy from one place the pen body and another one the pen cap, if you have 10 of these and 5 of these, and each one together makes a unit you can sell, again, 5 of these, 10 of these, how many can you make? Well, the answer is only 5, because you'll have 5 extra of these. These run out first. They're limiting. And in chemistry, it's the same sort of concept. So let's go through a problem like that. Thumbs up, people. Can you see in red 5 points? Thank you. You know something, let me change this. And instead of how much, I could have said how many grams of H2O. Actually, hold on. Let me clarify this whole thing. This is how I do it on the test. Every once in a while, that's the dangers of Dr. White doing it on the fly. This is better. All right, let's take a look at this. What are we being asked to find? How many moles water? What are you given? Well, I have 4.15 moles of hydrogen, and I have 3.75 moles of oxygen, and I have my balanced chemical equation. And this is a limiting reactants problem. And if we look at test number 2, important information, I see a question. All right, let's go back because I have a request to read the problem again. This way, if you react 4.15 moles of hydrogen with 3.75 moles of oxygen, then how moles, how many? We knew that word was in there. How many moles water will you make? I'm doing New English. Poor English bum, Dr. White. And the answer is yes. Someone corrected me. Thank you very much. Dr. White made a mistake. I'm going home. Wait, I am home. As I said the first day of class, I don't walk on water unless it's frozen. Even then I stay off it. So I will make a mistake, and I appreciate the person who found my mistake and let me know. Truly, thank you. And bad Dr. White. All right, so how do you proceed? We now go to important information, test number 2, and how do you proceed with limiting reactants? Determine the number of moles of product produced using the moles of each reactant, and the lower number of those two calculations, it's always going to be 2 in my class. It can be more, but for my class, I'll keep it to 2. The lower number is the answer. So the first thing we have to do is moles of product from each reactant. 2 steps. And just to remind you, remember.
Hey, Dr. White,
Yes.
can you read that one, please?
Need 2 steps, moles product per mole each reactant. Does that help?
Thank you.
Oh, a voice from somewhere. My speakers. Good news, Dr. White has his volumes cranked up. I have monster speakers right above my monitor and webcam, and that way I don't have to wear my hearing aids, which is a good thing. All right, let me just quick remind you something. A and B are reactants. Anything at the base of the arrow are reactants. Anything at the head of the arrow are the product or products, what you make. So for this case, we have 2 reactants, so we need 2 reactions and or 2 calculations. And the first one is whatever we have, the reactant in moles, we want to go to moles of the product, in this case, water. If I have a ratio, how do I get what's going in that ratio? I use my good buddy, my good friend, unit analysis. Whatever we're trying to get to goes on top. Whatever we're trying to go underneath or get rid of goes underneath. One thing I should point out, each step So for each reactant, you have to go from moles of reactant to moles of product. In this case, we have hydrogen, oxygen, and the product from our balanced chemical equation, now that it's balanced, is water. So now that I use my good buddy, my good friend, what goes on top? Moles of water. What goes underneath? Moles of hydrogen. And where do I get these two numbers? From the balanced chemical equation. And that tells me now that I've been corrected, bad Dr. White, for every 2 moles of hydrogen, I make 2 moles of water. For every 2 moles of hydrogen, I make 2 moles of water. So for every 2 moles of hydrogen, I make 2 moles of water. Remember, these are exact numbers. So this is 3 significant. Before I pick up my calculator, which you really don't need, but I still will check moles of hydrogen divided by moles of hydrogen. Anything divided by itself equals the number 1. And I'm left with the right units. So if all the hydrogen reacted, I would get 4.15 moles of water. Now, the other product, notice this side are the products, is oxygen. So for the second one, I have 3.75 moles of O2, and I want to go to moles of my product, moles of water. So I use my good buddy, my good friend, unit analysis, whatever I'm trying to get to goes on top. Whatever I'm trying to get rid of goes underneath. And now I know on top I want of this ratio moles of water. Underneath I want moles of oxygen. And now where do I get these numbers right here? From the balanced chemical equation. And when there's nothing in front of a compound, it's the number 1. So for every 1 mole of oxygen, I make 2 moles of water. For every 1 mole of oxygen, I make 2 moles of water because the coefficients give you molar ratios. So for every 1 mole of oxygen, I make 2 moles of water. And before I pick up my calculator, I'll see that my units cancel out to give me the right units of my answer. This is a very important step because I've seen students put things upside down and they get it wrong. And if they had bothered to check that our units cancel out, they'd realize, oh, I made this wrong. And let me show you in a second how you can see that. Moles of oxygen divided by moles of oxygen. And therefore, I'm going to get my right answer. Now, the following, if I can write it, I have 3.75 moles O2, and I wasn't thinking when I'm doing this problem, and I want to get the moles of water, and I got mixed up and I put moles O2, moles of water, and notice this does not cancel that out. For this right here, my final units of the answer would be moles oxygen times moles oxygen divided by moles water, which I don't want. So that's how you can tell your units are wrong. Let's see who asked that question. Hang on. Let's see. Liliana, are you talking about number 1 or?
Yeah. I wrote H2.
Let's look at the balanced chemical equation. For number 1, we're trying to find a ratio of what? not moles to grams. That's when you use one. You have to look at your units. That's why it's important to write them in. I have a ratio of moles of hydrogen to moles of water. And I get that from my balanced chemical equation. For every 2 moles of hydrogen, I make 2 moles of water.
Okay.
And that's where you get that. And it's a good question because these are confusing. When do you use what and what? And that's why I'm going over this more than once. So this was correct. Yay, Dr. White didn't make a mistake, which is always a good thing. And this also, you see why this is wrong. Because it is, because you get the wrong units of your answer. Well, let's go back and now we can do our 2 calculations. Actually, 1, 3.75 times 2. Hold on 1 second. And this is the number and 3 significant figures. That's 7.5. So let's first of all do this. Better yet, let's do this. Now, Kelly just said it's easier to read when I use colors. What colors is your favorite? I'm a red person. Well, all right. I'll alternate between red and blue, and I can do, all right. So, by popular demand, this is 4 point, and this is 7.0. And how do you find out what's the answer? The smaller one is the answer. And let me see what a question is. Oh, I know I do, but I'll still take, did I tell you guys my class is a democratic dictatorship? You get the vote, but I get to decide. All right, so what's the answer? Look out, Dr. White's going Technicolor on you. The answer is the lower number, and that's your answer. Because this is in excess, so this will run out before this runs out, and that's how you do it. And Kelly has a question, go for it. Either say it or type it out. Either way, I accept it.
Just to clarify for number 2, 7.50 is the answer because 3.75 is 3 significant numbers, correct?
Correct.
Okay.
And remember, the numbers that come from a balanced chemical equation are exact numbers. You can't have, if we look up here, you can't have 2.4 moles of hydrogen. No, it's got to be an exact number. It's a whole number, exact number is the proper terminology. And that's why for step 2, your calculation rounded off to 3 significant figures. Why? This is 3, These are exact numbers. This is 3. And that's how you do it. Remember, for this one, 2 steps, calculate the moles of product for each reactant, and the lower number is your answer. So I better give you one to do. Keep an eye on me. I've already messed up once with my balanced chemical equation. And remember, if you ever go out with lunch, breakfast, or dinner with a chemist, well, I always say, please pass the NaCl table salt. All right, let's take a look at this. And it's time for Dr. White to decode what I just wrote. If you react 8.11 moles of sodium, Na, with 7.11 moles of chlorine gas, Cl2, then how many moles of sodium chloride will you make? Again, if you react 8.11 moles of sodium with 7.11 moles of chlorine, then how many moles of sodium chloride will you make? And it's your turn to have some fun. Am I a nice person or what? I share the fun. Everybody start smiling. It's fun time. I say fun enough, you'll believe me. You'll even feel it. It is fun though, but I'm a chemist, so I'm biased. And while you're doing that, I'm gonna go out and look in the real world again. And they're still predicting 4 inches of snow tonight. Wait. Oh no, it went up. I always like the Weather Underground 10-day forecast because it goes up and down. Now it's 4.5 inches. Quick, go out, buy a lot of bread, milk, and all staples. Get 100 pounds of bacon, 100 pounds of flour, because you might be stuck in. I better get back to work. All right. I think it was in this class, there was a 50-50. Let me do this. Next time I'll use thumbs up. I see the last people finishing up their calculations. So I'll be patient. Oh my goodness, it's almost 11:30. Time flies when you're having fun with Dr. White in chemistry. I hope you are. All right, let's do this. All right, question is, if you react 8.11 moles of sodium with 7.11 moles of chlorine, how many moles of sodium chloride do you make? So what are we trying to find? Moles of sodium chloride, NaCl. What are we given? 8.11 moles of sodium and 7.11 moles of chlorine. And now we need 2 steps because this is limiting reactants. How do you know? When I give numbers for both reactants, you know it's limiting reactants, saying which one is limiting, runs out first. And how do you know what to do? You look at important information, test number 2. Remember, this file is in Blackboard in the lectures folder under the secret name, CHEMI 1211, test number 2, important information. And if you look at limiting reactants, you have to determine the moles of the product produced using each reactant. That's why we have need 2. I guess I could say steps or calculations. And the lower number of these 2 calculations is your answer. So let's get to work. So if I have 2 calculations, I have 8.11 moles of sodium. Why are we doing this? Because you want to go from moles of reactant to moles of product. And you want to do this calculation for each reactant. In this case, the first one is sodium. And I want to go to moles of the product. In this case, that's sodium chloride. And I use my good buddy, my good friend, unit analysis. Whatever I'm trying to get to goes on top. Whatever I'm trying to get rid of goes underneath. And where do let me write this first into units. And where do I get ratios of moles of sodium to moles of sodium chloride? I come up here to my balanced chemical equation. This tells me for every 2 moles of sodium, I make 2 moles of sodium chloride. And it's balanced too. Yay. So for every 2 moles of sodium, I make 2 moles of sodium chloride. Remember, these are exact numbers. Before I pick up my calculator, moles of sodium divided by moles of sodium cancel out because A divided by A equals 1, cancels out, it's gone. And now, due to popular demand, the answer would be 8.11 moles of sodium chloride. Now I'll do that for the second one, and I have 7.11 moles of chlorine. What answer do I want to get? Moles of sodium chloride. And I'll again use my good buddy, my good friend, unit analysis. Whatever I'm trying to get to goes on top, the units, and whatever I'm trying to get to goes underneath. I'll draw those, write those units in. And where do I get these two numbers? From the balanced chemical equation. For every 1 mole, remember when there's no number there, it's the number 1 is the coefficient. That's the number in front of any element or molecule in a balanced chemical equation. This tells me for every 1 mole of chlorine, I make 2 moles of sodium chloride. For every 1 mole of chlorine, I make 2 moles of sodium chloride. So if I come down here, for every 1 mole of chlorine, I make 2 moles of sodium chloride. And before I pick up my calculator, moles of chlorine divided by moles of chlorine cancel out because anything divided by itself equals number 1 cancels out, and I'm left with the right units. And now I'll go to my calculator. I get this number and I round it off to 3 significant figures. I'm in that rut today, 14.2. And due to popular demand, and I don't want to get people upset, I'll write the answer in blue. And now that's not the final answer. Remember, for this, the answer is the lowest of these two numbers. And you have to use your high-level math skill, which is lower, 811, 8.11, or 14.2, and time's up. That's our answer. This is not. And therefore, if I react those two amounts of sodium and chlorine, I would get 8.11 moles of sodium chloride. Now, if I were a mean, evil instructor, instead of moles, I give you grams, and that would put a whole level more. Because first, for each one of those, you have to go moles to grams, and so, nah. I'll just leave it at moles, because I like to be nice to my students. Shh, don't tell anybody. All right, you know what that means? We finished, you're welcome, Kelly. We finished the material to be covered for test number 2, which is what I like to do, finish about a week early. So everybody has plenty of time to practice. And I do. So we're done with test number 2 material, but we're not done today. Dr. White's going to not cheat you and let you out early, because I feel that's wrong to the students, because you paid for a whole session. I'm going to give you a whole session. That way you get your money's worth. So you know what time it is? It's new chapter time. And this new chapter, see, I can sneak the whistle in there too. This new chapter will be on gases, and it will be material not on test 2, but on test 3. 1, 2, 3. Anybody see the Bullwinkle and Rocky throws the balls up 1, 2, and the third one hits them in the head? If you haven't seen Bullwinkle and Rocky show on YouTube, you should. You're missing a lot of good stuff. including Captain Wrongway Peach Fuzz. Am I indoctrinated to Bullwinkle and Rocky? Yep. But anyways, new chapter. That new chapter is gases. Now think about it. Where you're sitting right now, and I hope this is true for everybody, you're surrounded by gases. We don't think about it, but the air around us is a gas. Next time you inhale or exhale, think about it. There's gases coming in and out of your body. And this chapter, we're going to learn about gases. I'm going to teach you some neat stuff. Oh, speaking about neat stuff, I forgot to mention this Thursday and Friday, we're going to have a real colorful lab. I guarantee it's going to be colorful. So don't miss out on Thursday and Friday because we're going to have a real colorful lab. Now, let's take a look at gases. As you all know, what's a gas? One of the three states of matter. Remember, solid, liquid, and gas. Now we're going to talk about gases. Actually, first of all, I got to open up the chapter. All right, thumbs up, people who see chapter 11 on your screen. Thank you. Remember, this chapter and following ones will be test number 3 material. All right, when we talk about gases, the behavior of a gas, gas consists of particles that are relatively far apart. Oh, by the way, switches off for them on this slide, click, but it's still important background information. So when you think about the gas surrounding you, the air, its particles are really separated far apart compared to solids and liquids. In other words, it has, i.e. means that is, low densities. Gas particles are moving rapidly about. Right now, you're being hit all over the place with gas molecules. Oh, ouch, there, no. Why don't you feel it? Because all your life you've had that experience. But you know when you feel it real good? When you go outside, you can feel the wind on your face, or, well, what's left of my hair or my beard. But when you feel the wind and you see the wind moving like trees, or I have in front of my house these beautiful big wind chimes, are so pretty to hear, so beautiful. And that's molecules hitting it, going at a very, very fast rate. And the gas molecules collide with themselves, but there's little effect when they hit each other. And the thing you learned about, gases have indefinite volume, they'll fill the container they're in. So let's move on. Now, there's something called the kinetic theory of gases, and I'm going to turn the switch off, but I still want to cover it. And the kinetic molecular theory of gases, the first one is a gas consists of small particles, atoms or molecules, moving randomly with rapid velocities. Velocity means both speed and direction. It's a vector, for those of you who have vectors in math. And it's a collection of particles always moving. And the attractive forces between the particles in a gas is negligible. You can neglect it, forget about it. Now, the actual volume of a gas or occupied by the gas molecules is extremely small to compare to the gas volume that the gas operates. And the average kinetic energy, how fast it's moving, of a gas molecule is proportional. And this is important. We'll see later on this chapter. Gases for this chapter are measured in Kelvin, not Fahrenheit. Well, you do measure it in Fahrenheit or centigrade, but you convert it to Kelvin. And the higher the temperature, the more energy it has, kinetic energy. And the speed of particles increase with increasing temperature. And gas particles are in constant motion, moving rapidly in straight paths unless they hit something, sort of like billiard balls. I haven't played billiards in ages. I was never good at it. Tennis was my thing when I played sports. Now, when we talk about gases, there are key properties of gases. One is the pressure, the other is the volume, next one is the temperature, and finally the amount. And the amount is usually grams or weight, which you know how to convert weights to moles, which is important to use with properties of gases. So when we talk about properties of gases, the first one I like to talk about is pressure. Switches off for the slide. And that is, what is pressure? Well, pressure by definition is force applied per unit area. That's the total force on a surface divided by the area of that surface. Pressure equals force per unit area, sometimes called. This switches off on this slide. I've now turned the switch up to 20. If it only goes up to 10, you have a dial that only goes up to 10. I've just turned it up to 20. By the way, I stole that from the movie. This is Spinal Tap. It's a cult movie. If you've never seen it, it's pretty bizarre, but interesting. And they, in the movie, they say, we're so loud, we turn our amps that only go up to 10, we can turn them to 20. They can't, but it sounds good, and I like to steal things that sound good. All right, pressure. How do we measure it? Well, think about it right now. You don't feel it, but gases are pushing all over you. Oh no, don't worry. Since you were born, that's happened. And you just learn to ignore it. What is that pressure called? Well, when we're talking about the air around us, also known as the atmosphere, we call that the atmospheric pressure. And how do you measure atmospheric pressure? With a barometer. How many of you have heard that in a weather report, they say the barometric pressure is such and such? And I think you've all done that. In fact, let's do something real quick. Maybe not real quick. Why is my internet's, there we go. Now they're saying on this one, 3 to 5 inches. The snow. Oh no, quick. Go out and get more gas for your snowblower. All right, thumbs up, people. Do you see additional conditions on your screen? If you look here, this is from the Weather Underground. That's the one I like to use for weather. I'm in Schaumburg, so I'm going to pick Schaumburg, and the pressure is 30.24 inches. Now, this is the barometric pressure. How did they get this number? Using a barometer. Don't you love Google? All right, everybody see the picture of barometer with a tube, vacuum, and all that on your screen? Okay, this is the original type of barometer. It used mercury. And what happens is the atmospheric pressure pushes down on this pool of mercury, a dish of mercury. And originally you had a vacuum in this tube, and that pressure pushes the mercury up the tube. And the difference from where you are, the top of the pool of mercury, to the top of the mercury in the tube, you can measure. Now, in this case, they measured millimeters. In the United States, we use inches, which is why you have millimeters of mercury or inches of mercury in the United States. And that pressure where it has inches really should be inches Hg. Now, because mercury is a very dangerous hazardous material, we no longer use it. If I look at the clock, oh my God, I'm almost out of time. But mercury we don't use, and we now have electronic devices, which and other sensors that you can get that pressure. And we use a barometer to measure the pressure. Now, in science, we don't use inches, we use millimeters. Someone started instead of centimeters, millimeters, Hg of mercury, and that's atmospheric pressure. Now, the person who first measured barometric pressure and came up with the barometer, the picture I just showed you, was a great Italian scientist, Torricelli, or Celli, I don't know which is the I always say Torricelli. As you can tell, I use my North Side Chicago Italian accent. No, I'm not Italian, but I do love the old Parmesan. Oh, I shouldn't talk about that now. But anyways, 1 millimeter mercury equals 1 torr. And this will be given to you in important information, but for now, one millimeter mercury equals 1 torr, and that's due to the fact that we honor great scientists by putting their name, or in this case, abbreviation, torr for Torricelli, in the name of a unit. And now when I look at the clock, oh no, I'm out of time. Hopefully you had a fun morning with Dr. White. Don't forget, on Wednesday, I'll continue chapter 11, but don't forget to do your chapter 8 problems for the lab Thursday and Friday. Don't forget the hand in the lab that's due Thursday or Friday. And if you're late, if you have any back labs, I'll extend the amnesty, maybe 1 or 2 more days if you have a good reason. Don't tell the instructor I said that, okay? And with that, I'll see you on Wednesday. Gang gesund. Goodbye. And don't forget, I have my office hours, so I better say it again. Gang gesund, be healthy. Goodbye.